My name is Alex Rodling. I'm with the MySQL team. And with us today is Sarah Novotny. She's a founding partner of Gecko that provides remote administration and management of databases around the world. And there she's a senior administrator of the MySQL and LAMP practice. So please welcome Sarah.
Hi. I'm assuming that all of you work on databases here and there. This is an Oracle conference and everything. So what I really want to do is kind of highlight the ways the information you know already about Oracle databases can be used and expanded to take a look at MySQL databases. So we'll have to see. There we go. So the first things I'm going to talk about are language. So we're going to try and come up with some common language because MySQL calls things a little bit differently than Oracle does. Oracle has some very specific terms. I also want to talk about user management and security because that looks very different in MySQL than it does in Oracle. We're going to talk about some things that Oracle doesn't even really have. So Oracle doesn't have storage engines. The whole concept of a storage engine, as far as I know within Oracle, doesn't really exist. And a lot of the logic for MySQL exists within the storage engine. I'm going to talk about backups and replicas because everyone who manages or maintains a database should, of course, be taking backups and keeping replicas around. Monitoring, everyone needs to do monitoring. Again, a really good point. And then lots and lots of tools at the end. We're going to see a couple of them as I go through some of the slides, but for the most part, what I really want are a list of tools and references that you guys can work with. Now, today is in fact International Talk Like a Pirate Day. Oh, I thought I fixed this slide. It's not that kind of pirate, it turns out. It's that kind of a pirate. So, Avasti mateys, here we go. Common languages. So, MySQL actually refers to a database and uses database to mean a multitude of things. Now, within Oracle, the database is generally this set of files on disk. Then there's the instance, which exists in memory, the schema, which is a portion of the database that you can see, and then, of course, we have other things here on the list. But schemas, instances, and databases are used very differently within MySQL. Database means all three of those things in MySQL. So it's occasionally really hard to have a conversation with a client where you say, so we're connecting to which database, and then we're going to be looking at which database, and then we're going to be actually querying which database. So that means three separate things. So what I generally do is I actually make use of the Oracle nomenclature to clarify the instance that we're connecting to. So that would be a port and a memory construct. And then the schema, which would be the user database in MySQL language, in order to be more clear about what we're talking about. I'm also going to try and talk a little bit about the actual instance and the different portions of the instance and how you might be able to see that and consider it within MySQL, what goes into the SGA, the PGA, the UGA, and then we can talk a little bit about file system layout. So, okay, so my remote's not working very well. So the SGA within Oracle kind of gives you the construct in memory that everyone and all of the connections, all of the database instance makes use of. Now in MySQL, we think of that as the total system level memory, and it is it's made up of a set of variables that are set up for each instance within MySQL. It gives you the query cache size, which is used across the entirety of the actual server. The InnoDB buffer pool size, which is, we heard a little bit about InnoDB becoming the the primary engine, the actual default engine, storage engine for MySQL as of 5.5. And so the InnoDB buffer pool, the InnoDB additional memory pool size, the log buffer size, all relate to that storage engine. And they're used only by that storage engine. So some queries that connect to different storage engines would not actually go through that system, those system memory constructs. And then there's a key buffer size as well, which is your index buffer size. So that's kind of the system global area for MySQL. The user global area is more the memory constructs for each thread. And that actually has a whole nother set of variables that go into it. And understanding what each of these do and how they interact and work into each thread and trying to actually allocate and tune these is another longer conversation. But the thread stack size, the net buffer length, the max allowed packet size, these all add up to be the memory allocation per thread. So that's more of the, approximately the user global area. There is not direct translations on a lot of these things. There's not exactly the same sort of language, not exactly the same sort of memory construct, not exactly the same sort of use cases for all of these pieces of Oracle. But I'm trying to give you some approximate correlations. So the total memory that you look at and you work with within Oracle, or within MySQL, is in fact the thread memory plus times the number of max connections plus the system memory available to you. And that is most of the time true. The caveats there are, of course, that MyISOM, which is the default storage engine prior to MySQL 5.5.6 release candidate that we heard about this morning, is MyISOM. So MyISOM does not actually use a system global area for its buffering. It actually uses file system buffers. So when you're allocating memory within MySQL, in order to make best use of your server, to make best use of the hardware given to you, choosing very carefully your storage engine, which I'll get into a bit more later, choosing very carefully your storage engine and choosing how to mix those if you need to mix storage engines, then it's a really important decision to make. Do you want to have only MyISOM, only InnoDB, one or the other, and for which reasons? So we'll talk a little bit about that in a minute. The next big thing to talk about is file system layout. So I'm a big proponent of MySQL RPMs from mysql.com. That chooses the Linux standard file system layouts in order to handle and simplify and manage and integrate the binaries, the libraries, the man pages, and the info pages right into the standard architecture on Linux. My world is almost entirely Linux, so I can't really speak very well to the Windows side of the world. But I'm a big fan of the RPMs, and this allows us to give you a file system layout. You find things in user bin you'd expect to, you find things in user S bin you'd expect to. But the biggest space to know about is the data directory. And the data directory actually has your data files, your index files, your log files, and the true meat of your database. That's the space that is most often moved around, most often split out to improve performance, so you could put data files in one place and log files in another place as an architectural decision. And that's where most of the meat of the work happens. The binaries stay where the binaries are, but there's not really a corollary to Oracle Home within MySQL. So I do want to go through a tiny diversion here. MySQL High Performance Second Edition, or High Performance MySQL Second Edition, is a fantastic book. It's written by the guys from Percona, and they have an excellent architecture of the server section, which includes this photo, which tells you a little bit about how the simplified core of the server works, simplified compared to Oracle. You have your connections and thread handling, you have a choice of going to the query cache or the parser, you move it through the optimizer, and then it actually asks the storage engines for the data, and occasionally, depending on the storage engine, some of the work happens within the storage engine as well. But I do always want to call attention to that book. It's a really fantastic book. The next big point that I wanted to hit was user management and security. I was always confused by Oracle having a user equals a schema In MySQL, those things are separated. So user doesn't actually equal a schema. And I know that there are spaces where it doesn't have to in Oracle, and you can grant users access to other schemas and the finer points there. But within MySQL, a user plus a host is given access to a schema and a set of tables on that schema. So you would grant select to the user Sarah on a particular schema and a particular table, or you would grant select on a schema and a table to the user Sarah coming from localhost. And that's different from the user Sarah coming from a host name. It's also different from the user Sarah coming from anywhere. And there is a hierarchical way that the internals of MySQL go through the permissions here. And it is going from the most specific, being an IP address, to the least specific, being a wildcard. So working through the privileges and the actual grants, it always goes from least or most specific to least specific. And my first week on the job, flush privileges is really important. I spent a good 2 hours trying to find that the first time, but I added the user. But I'm sure it's right, but it says I'm coming from the right place. You need to make sure to flush the privileges once you actually make any grant changes or additions. Another thing, which actually is fairly common across all good security practice, is use the minimum privilege necessary. One of the things that we have run into as a firm that touches databases everywhere is that customers are often lazy. Even the really, really good customers are often lazy. So we will find that everybody is connecting as the root user. Everybody is connecting as a user that has all privileges across all databases. Now this has, of course, some security concerns, but even more than the outside external risk of security concerns, it has stupidity concerns. We had a client about 2 weeks ago where a developer doing exactly what he should errantly pointed a script at a production database and truncated 65 tables. That is not a fun thing to recover from. He could have been stopped. He could have been stopped by having minimal privileges. Maybe he didn't have the truncate privilege. He could have been stopped by not logging in as the root user everywhere. So this is just a reminder to everyone who knows not to do this, that this is something that can really, really bite you. Whoops. So I talked a tiny bit about storage engines. MySQL has this concept of the storage engine. It is the place that the data actually goes, and it looks very, very different from anything I'd ever run into before MySQL. The way that the engine and the internals are written is different and optimized differently for each engine as it's written. So InnoDB is far and away the best option in my estimation. Does anybody here, or how many people here use InnoDB? Woo, we have some answers, yay. How about people using MyISIM? I won't chastise you, I promise. Okay, there are really good reasons to use MyISIM sometimes. MyISIM is also the default storage engine, so sometimes you forget to change it as you're making changes. All of the MySQL internal tables are also in MyISIM. I list a few more storage engines there that are useful for different things, and I'll go through them a little bit. The big thing about InnoDB is it gets you the things you as Oracle users would expect. It gets you ACID compliance, it gets you transactions, it gets you rollbacks, it gets you all of the important things that you actually rely on and assume are happening in a database. MyISIM doesn't. MyISIM locks very differently as well. InnoDB does row level locking. MyISIM does table level locking, which when you're doing high concurrency is a nightmare. The merge table, or the merge storage engine, is sort of poor man's partitioning. Before 5.1, there wasn't real partitioning within MySQL. And so merge gave you that. Merge said, here are a bunch of MyISIM tables, and we're going to treat them all as one single table, even though they're in separate data files. So that's another thing within MySQL that is fairly different from Oracle, within MyISM specifically. InnoDB can go either way. Each table is related to a set of files. You don't actually have a data file set or a data file that is identified to go with a series of tables or with a schema. Within InnoDB, you can do that in some specific cases, but again, it's very different from the Oracle world. InnoDB has more of a set of, these are the data files for all of the instance, or you can have a set of a data file per table. But there's not really that in-between space where you could say, I want these schemas to go into this data file as more of a collection. That doesn't really exist. The black hole engine is a nifty little treat. The black hole engine is set up to write all of the data that goes into the black hole engine into a log, but never actually write it into a data file. So it pretends it could use it, pretends it's there, but it doesn't actually write it into a file. It's really useful for some complicated replication strategies. Archive engine is actually optimized for insert-only data and fast reads. So that's something that you want if you are, I don't know, writing logs into a database for some reason. And federated is just kind of like a view across to another database, to another database on another server. So that's another storage engine. But they're all written with the mechanics of the engine and the optimization of the storage within the storage engine instead of within the database binaries in the database engine as well. I touched on locking for a moment. It's a really, really big difference that I can't stress enough between InnoDB and MyISM, those being the two most common storage engines. InnoDB is row-level locking. MyISM is table-level locking. Table-level locking is a pain, just universally. Row-level locking, though, can still be a problem. If you have a lot of contention on a database, actually I think this one was doing table-level locking. So we are creating something here, and we have an update and a select that are locked behind it. So within MyISM, even the reads are blocked behind a write. I changed the names on that to protect the innocent. So backups, another very, very important point in all of this as we talk about operationalization on new databases. I can't stress enough, take them and test to restore. That customer that I talked about who had 65 tables truncated in production had taken backups, absolutely. Knew they were there. Had backups from 3 weeks ago, because I know I don't have regular automated backups yet, but we'll get there. Actually, entertainingly, their CEO was really pleased that they were going fast enough in the development to fail by not having backups. I thought that was interesting. But they hadn't tested them, and they didn't realize that they actually had a gap in their transaction logs from the time that they took the backup and knew they had a consistent backup to the time that they actually started having transaction logs. So they had a backup from the 27th of July, and then they had no logs to apply until the 5th of August. So there were 8 days, 9 days, something like that in there, where they didn't know what had happened in their database. Now, fortunately, there are ways to recover in that situation, and I don't recommend any of you ever call me for that. But their data did come back. Backups in MySQL are an interesting space. Because you have the storage engines, each storage engine behaves differently, so getting a consistent backup looks a little bit different depending on the storage engine choices. So MySQL dump is not always a valid backup. Because of the way the locking happens, you can lock each table, and you'll have a consistent table, but it doesn't lock the entire database, the entire instance, all of the schemas at the same time. So you will have inconsistencies between tables. Now there's a way to do that if you have all InnoDB tables, and that would be to do it as a single transaction. So if you have some MyISM tables and some InnoDB tables, a MySQL dump will not actually be a valid backup. The easiest way that I've always found to take a backup is to actually make a replicated slave first. Now this would be a logical slave for those of you in Oracle's world. This is not a closed slave that is applying block level changes. This is actually, up until 5.1, it was all statement-based replication. So your database is open and available to you, and your statements are rolling over and being applied to the data. Now it also means that people can connect to the database and alter it, and bad things can happen. But it was all statement-based until 5.1. 5.1 brought in mixed mode replication and brought in the possibility of row-level replication. It took a long time to get that stabilized, and I still prefer, strangely, the statement-based replication in it, but it has gotten a lot better. Mixed mode I'm still scared of, but row-level replication is pretty good. So having a standby and taking a cold backup of it every night is awesome. That's the easiest, cleanest, most consistent way I know to do it. And you have a warm standby, just in case you need something to flip over to it immediately. InnoDB Hot Backup, which I saw this morning has been rebranded to MySQL Enterprise Backup, is a great tool. It does something much closer to what Oracle does for backups, kind of tracking the SCN in order to know how many changes to have to apply and what transaction numbers it has to apply afterward. Extra Backup was the free version of that. That was also written by the guys at Percona, so another shout out to Percona. And then MyLVM Backup, which is a lot like RMAN plus snapshotting. It locks things really quickly, takes a snapshot, and moves on. I think that's the way RMAN does it. My Oracle is not as deep as my MySQL. Cloning, which is what my LVM snapshot does, or my LVM backup does. Cloning is really useful for a couple of things. Cloning is awesome for being able to stand up environments for people to test on. I keep clones around as often as I can, and just as often as I have actual slaves. Because doing a clone and doing a MySQL dump give you two very different options for recovery. A MySQL dump gives you a logical, I have to import all of the data straight from here's the create table statement to insert all of this data. A clone gives you the binary copy. Now, that's really handy as long as you absolutely know that your file system that there's file system integrity, you don't have problems with in the database. So exercising your backups is always a must. The clones, we've run into problems occasionally with clones. We had a 1 terabyte table that had a corruption in it, and then the clone that existed had the same corruption, but the MySQL dumps didn't. So we were actually able to import the MySQL dumps that existed from this 1 terabyte table. It took a really long time, let's be clear. As we were doing that import, we actually saw that, that the import time was increasing with every statement because the size of the index for the 1 terabyte table started falling out of memory. And so as it fell out of memory, the import time went from, here we're importing 10,000 records in, 0.2 of a second or whatever, to all of a sudden we extrapolate out as this curve goes up. Oops, the curve goes up this way. It's going to take us 6 weeks to import that data. That is not an acceptable answer. We ended up having to do an on-the-fly upgrade to 5.1 and implement partitioning in order to actually import that data in still only about 5 days. Monitoring. Now that we've got your database set up, you kind of understand where the memory is, you understand that you want to make good choices about what your storage engine looks like, you understand how you're going to back it up, you want to make sure that you know when you need to work on it. So you want to monitor things on it. The MySQL Enterprise Monitor has grown pretty robustly in the last couple of years, and there's some really neat stuff in it. I like some of the predictive things in it. It says, hey, this might be a problem in a while. I like some of the, we saw a bunch of slides of it this morning in the keynote. I like some of the analysis it gives you. Here are some of the things that are in your slow query log, and here are some ways you might be able to handle it, fix it now. My company tends to use Nagios. I'm a big fan of open source, and I'm an even bigger fan of free, even though it counts as free like puppy, not free like beer. So I'm all for digging in and cleaning up open source projects and such. So we ended up going with Nagios. We've written some tools on top of that in order to monitor both Oracle and MySQL and now SQL Server more deeply than the base plugins within Nagios. The key alerts, though, that you're going to be wanting to watch: connections, pretty standard stuff. Caches, making sure you understand how your caches are being used, are they the right size. Lock contention, it's a big problem in any database. Well, any database that is moving rapidly on things. And then, of course, your basic server metrics. Lots and lots of stuff, good stuff in there to keep track of. My next short diversion. I love throwing these in because they don't really fit, but to swap or not to swap. I remember the first time I set up an Oracle database for my partners, because they do the Oracle administration in our world. They told me they wanted 4 times the physical memory in swap. Okay, sure, we'll set that up. Most servers I'd set up till that point only had 2 times the physical memory in swap. We had some discussions about why they wanted so much, what for. The big thing within MySQL to think about around swapping is, of course, you don't ever want the binaries to swap out. You don't want the buffer pools to swap out. And specifically in MyISAM, you want to make sure that you have enough file system cache that the MyISAM tables will actually be cached. So the InnoDB buffer pool, you want to be pinning in memory. And you want to also have space for the MyISAM caches, or the MyISAM file system caches. Or if you're running one or the other, you want to make sure you're running it so that you have that space. So swap is less of an issue. The one thing, in a case where you're running only only InnoDB, and you're running it really close to the physical memory of the machine, and you don't want the buffer pools ever to cache out, even if something insane happens on the machine, you want to enable huge memory, or huge pages, huge page support within MySQL. That will make sure that the Linux kernel doesn't swap it out to disk, but it doesn't allow the machine to crash if you have no swap. So there's kind of this in-between space. Your performance will go awful, of course, but your performance would become awful if it swapped out. It would become more awful, actually, if it swapped out. You would have the machine stay up, you would have the processes stay up, and you would still be able to get in and be interactive with the machine, which is the problem when things swap out, is you really want to still be able to get in and look at the machine. I have a list here of free tools. I talked about a couple of them. One of them, the big black screen you saw with the locks on it in the red. I didn't mention it, but that's InnoTop, a great tool that gives us a view into the MySQL database that looks a lot like Top, which many of you who are familiar with Linux, again, my world Linux, looks a lot like Top. MatKit is another tool. I didn't talk at great length about anything that I did with MatKit before, but MatKit is a tool that has many, many, many different pieces, and it can do things like archive things out of tables. It can do things like do slow query analysis. It's got dozens of tools. It's a really, really neat tool, and I strongly recommend that everybody play with it. MySQL proxy is another thing that exists by MySQL, now Oracle, and we've used that in a number of cases to put it between a client and MySQL in order to see what's going on. Another trick in that space is to look at the TCP dumps, and MatKit has a tool to take a look at the TCP dumps to be able to see what the clients are handling. Monitoring and trending. I love Nagios, as I mentioned earlier, and there's a whole set of cacti templates that are really useful for trending. And generally, I recommend a monitoring server that you know. It sounded like in the keynote this morning there's lots of integrations coming, both now with the MySQL Enterprise Monitor into the Oracle cases, as well as in the future in the OEM, Oracle Enterprise Monitor, OEM, into the in MySQL. So that sounds like it's coming. I think the date I saw on that was 2011, so we've still got a little bit. But if you know a monitoring server, it's the right one to pick. Just as long as you're monitoring, like I said, I was going to harp on monitoring here. As long as you're monitoring, you're getting way ahead of a lot of other stuff. Additional resources, for those of you who are just coming into MySQL, there's an awesome IRC channel that has really, really smart people that are on it all day long, and they answer questions, and they're really, really nice about it. It's sort of like OTN interactive, the way I think of it. MatKit has the same thing, an IRC channel. It's a little less active, but I think that's because it's primarily the developers for MatKit. MySQL.com has great references, now running, working with Oracle. And then I mentioned earlier, high performance MySQL 2nd edition. The key thing there is don't buy the 1st edition. The 1st edition is dangerous to your databases today. Unless you happen to work for the government and are still running 4.0. I heard about that earlier. Or maybe it was 2.0. That scared me. So some credits on my images for y'all. And then my information. I've put these slides up already on SlideShare. So you're all welcome to look at them there. There's my contact info. You're welcome to harass me. And I also have 6 or 7 minutes for questions. Maybe even 8, if anybody has some. And there are mics. Or we'll go get cookies. Nothing? Okay. So WAN level replication, it exists now. It can be handled with the statement-based replication. We actually have a client who does a 4-site loop. I will never recommend to anyone loop-based topology for replication, but occasionally it's important. This is a 4-site loop that includes going across the Atlantic Ocean to London. So you can do WAN-based replication as it exists. It's built into the MySQL server. So you would actually, I think the commands right now, so you say, you set up your server IDs within MySQL, and then you say change master to, you give it the master host IP address, port, the user it's connecting as, and what you want to be replicating. And then it begins replicating for you that way. So it's built into the server. If you do a quick search for MySQL replication on MySQL.com, you should come up with a lot of good information there. More questions? Yes? What is the database size limit in the case of MySQL? Big means a lot of different things in a lot of different ways. I've seen multiple terabyte databases in MySQL. They don't go fast, and they do go fast in some cases. It really depends on what you're trying to do with them. But there, as far as I know, there is no hard limit. It is just a, it's just a how big and how slow or how fast you need it to go for what. Well, yes?
If you wouldn't mind, could you do a compare and contrast for Oracle partitioning and sharding?
Ooh, Oracle partitioning and sharding. I don't know if I can compare the Oracle partitioning portion of it. I can describe sharding. Okay, so sharding is a concept that MySQL DBAs used for a more of a logical partitioning of data. It happens most often at the application layer as opposed to at the database layer. So it would be akin to saying, everybody born in January, your user information is on this database. And then you write an abstraction layer between the client and the database that says, great, these users are based on this hash or this key they are handled in this database, this physical server, and this physical server, and this physical server. So it's partitioning across physical hardware. Within MySQL 5.1, there was the addition of partitioning of tables within a single database server, within a single instance, and that was added and has since, depending on what you're trying to do, that's also a really useful solution. But sharding became the common buzzword and common choice for large-scale, highly rapidly growing applications. Does that answer enough of your question? Okay, thank you. Next? Anyone else? Yes? How does MySQL handle encryption or compression? There are configurations for SSL connections to MySQL. I have not found very many people use them. And compression, there is a compression flag for replication. I don't know if there's a compression flag for just like client request. Right. Right now there is nothing that does encrypted backups. Not that I've found anyway. More questions? I think I'm about to get like a 1.5-minute flag here somewhere. Okay, well, thank you guys.